Alright, welcome back. In this video, I'm going to be working quiz 10.3 for Algebra 2. And this is more rational functions, more sketching functions, more asymptotes, but now I think we're mixing in some holes in graphs. Alright, so the first one is there is a hole in this graph at A and B. Find the values of A and B. So what we're going to do is we're going to need to factor. We're going to need to factor the top and see if it cancels off with the bottom, and it had better, or else I'm not going to have a hole. So I'm going to say y is equal to, I'm going to factor out the 2 because I see an even number on all three terms in the top. So I'm going to factor out the 2. And I'll have x squared plus x minus 6. Got ahead of myself. And then I'm dividing by x minus 2. Okay, but the quadratic in the numerator, that can be factored. I can think of two numbers that multiply to negative 6 and add to 1. That would be 3 and negative 2. I can cancel off the x minus 2's, which means that I'm going to have a hole. So basically the graph would look like y equals 2 times x plus 3, which would be 2x plus 6, with a hole at x equals 2. Whatever would cause the factors I canceled to equal 0. Whatever would cause me to have 0 over 0 in the original statement of my function. And to get the y coordinate of the hole, I plug the x coordinate of the hole into the new simplified version. So I plug in 2 there, so 2 times 2 is 4, plus 6 is y equals 10. So my value of a is 2, my value of b is 10. Number 2 is going to ask us to sketch a graph of y equals x to the 3 plus 2x to the 2 plus 3x plus 6 over x plus 2. Alright, well that's going to be, we're going to need to factor the top. Okay, so it looks like something I can do group and factor with, so I'm going to factor out an x squared from the first two terms. I'm left with an x plus 2. Yeah, and that looks good because I can factor out a 3 from the second two terms, and I'm left with another x plus 2. And I've got x plus 2 in the denominator. And then I think I've got enough room to get one more to the right, so I factor out the x plus 2. I'm left with an x squared plus 3. And I'm going to divide by x plus 2. So I cancel off the x plus 2's. And I see that, okay, the graph I'm looking for is y equals x squared plus 3. We know how to graph that. With a hole at x equals negative 2. Now we could go in and plug in negative 2 and find that the y coordinate in the hole is going to be, I guess, 7. But that's not really what it's asking us for. It's asking us for a sketch of the graph. So we know what y equals x squared plus 3 is going to look like. It's going to start off at 3, wherever we decide that's going to be, and this is going to be a standard parabola otherwise. I just need to remember to make room for a hole at x equals negative 2. We can just kind of decide wherever we want that to be, or maybe about there. I'll just make the parabola fit with that. And that's a perfectly good sketch. And I guess what I could do to make it better would be, it's a little off, I could label that as negative 2 and label my axes, but that's a good sketch. Right. Number 3 and 4 is going to ask us about this function g. Okay, so the domain and range. Domain is going to be, okay, well, I need to find where 4x plus 12 is not equal to 0. Okay, that would be where 4x is not equal to negative 12, so x is not equal to negative 3. And as far as the range, I'm not sure what y'all ended up doing, you know, as far as your technique there, but what it's going to end up being is you can divide the leading coefficients, and it's just going to be like, okay, y is not going to be able to equal 12 over 4, which is 3. So y is not going to be able to equal 3. In this case where we have linear over linear. But, you know, nobody instructed you to do long division. Maybe you did do long division to rewrite g of x, and if you did, then you might have been a little more certain that the range was going to be y, not 3. But I'm going to just stop there for now. The x and y intercepts on the graph of g. The x-intercept, that's where y equals 0, and this is kind of the first time I told you, okay, if a fraction is going to equal 0, it's only because its numerator is 0 and its denominator is non-zero. So what we would do is we'd say 12x minus 9 equals 0, add 9 to both sides, divide by 12, and I get 9 over 12, which is the same as 3/4. For a y-intercept, I'm going to set x equal to 0. I'm going to say, all right, well, y is going to equal 12 times 0 minus 9 over 4 times 0, which should not be 4, it's 0, plus 12, and I get y is negative 3/4. All right, on the back, I've got another one of these. It's like, okay, linear over linear. But first it's going to ask me to do polynomial long division to rewrite f of x. So, or you can do this. 4x minus 19 divided by x minus 5. Okay, so I think to myself, if I multiply x by to get 4x, then that would be a 4. I'm going to move this down a little bit so I have plenty of room. So I have 4x minus 20, and if I subtract this, 4x minus 4x is 0, and negative 19 minus negative 20, that's negative 19 plus 20, that's going to be 1. So plus 1 over x minus 5. So my rewrite would be f of x is 4 plus 1 over x minus 5, making it look exactly like those ones that we were graphing last time. Okay, find the equations of vertical and horizontal asymptotes. Well, now that we've written it like this, I'm going to say vertical asymptote would be x equals 5. The x coordinate that causes me to divide by 0, and the horizontal asymptote is going to be y equals 4, because the bigger x gets, the closer I'm getting to y equaling 4 plus 0, right? Because x minus 5 gets bigger and bigger and bigger, 1 over a huge number, that's a really small number. Okay, and then sketch the graph of y equals f of x. So if I've got 4 plus 1 over x minus 5, I just mentioned the horizontal and vertical asymptotes. Maybe I'll sketch this one a little bigger and hope it works out better for me. Sketches lately have not been great. Alright, so I've got, that's y equals 4. This is going to be x equals 5. I'm going to use like a thicker pen and see what happens. Okay, because it's positive 1, yeah, 4 plus 1 over x minus 5, I'm going to have a standard 1 over x type graph. Right, and I can come back in with the axes and say, all right, y equals 4, that's above the x-axis. And x equals 5, that's definitely above the y-axis. Think about this. Okay, what's the y-intercept going to be? 4 minus a fifth is definitely a positive number, so I need that to be over here. Okay, yeah, that did end up being better. So, if your sketches are not doing good enough, you maybe just use a little bit more space it out, and could end up looking better. All right, number 8. This is one, find the equations of vertical and horizontal asymptotes of the graph of h. All right, the horizontal asymptote for this one is going to be y equals 0. Because on one hand, you can think about it, 2 over something, that's not going to equal 0. Or you could say the bigger x gets, the bigger that quadratic gets, because that's a secondary polynomial with a positive leading coefficient. And so the denominator gets bigger and bigger and bigger, dividing by a bigger number, that's going to go 0. Go towards 0. Not going to actually equal 0, though. And as far as our vertical asymptotes, we need to figure out where the denominator equals 0. So it's going to get you to factor one more time. So what are two numbers that multiply to negative 15 and add to negative 2? That would be 5 and 3, but probably negative 5 and positive 3. So my vertical asymptotes would be x equals 5 and x equals negative 3. Alright, now we're going to move on to form B. So the graph of y equals 6x squared plus 6x minus 12 has a hole at a and b, so I'm going to need to factor and cancel. So y is going to equal 6 times x squared plus x minus 2. That would be divided by x minus 1. I can rewrite that as 6 times, factoring the top, that's going to be x plus 2 times x minus 1. Okay, so I'm going to cancel off the x minus 1s, and so my graph would look like y equals 6 times x plus 2 is 6x plus 12, with a hole at x equals 1, because of the factor I canceled, and the y-coordinate, I'd plug that x back into the simplified version. I get 6 plus 12 is 18, so that means that a is going to equal 1 and b is going to equal 18. Number 2 is going to ask us to sketch a graph, And I think this needs to be an x plus 3 in the denominator. Remember, there was something off with this quiz. So yeah, once we made that an x plus 3, this was a graph we could sketch. Otherwise, it's going to be really bad. So, and the type of thing that we aren't, in the middle of learning about how to sketch. So I'm going to go and I'm going to factor the top. X squared times x plus 3 minus 2 times x plus 3. All divided by x plus 3. I factor out the x plus 3's. I'm left with an x squared and a minus 2. And I'm going to divide by x plus 3. Cancel those off. So my graph is going to look like y equals x squared minus 2 with a hole at x equals negative 3. Alright, so we can sketch the graph of y equals 2 minus x squared. Remember to leave room for a hole in the graph, like, I don't know, right there. And make sure that's negative 3 and that's negative 2. Figure's probably not going to scale, but that's okay. That's going to be a good sketch. Alright, this next one, domain and range. Alright, domain. It's going to be x is not equal to negative 2, because negative 2 is what would cause me to divide by 0. Okay, 6x plus 12 can't equal 0. You could solve that out. Domain is not x equal negative 2. X is not equal to negative 2, right? That's the value we have to exclude because it causes something bad to happen. And then the range, these are the set of actual outputs that I get from the function. That's going to be y not equal to 12 divided by 6 is 2. And you can either just remember this ratio of leading coefficients when it's linear over linear, or you could actually do the long division, but I'm not going to do that for you. If you need to do that long division yourself, you feel free to do it. Then you might feel a little more certain about it, but I think a lot of people in my class were just going straight for ratio of leading coefficients. So x and y intercepts on the graph of G. Right, for an x-intercept, we're going to set y equal to 0. And y, in this case, is 12x minus 9 over 6x plus 12. But if we've got a fraction equals 0, the only way that can happen is if the numerator is 0. So I'm going to say 12x minus 9 is equal to 0. Add 9 to both sides. 12x equals 9 divided by 12. X equals 9 divided by 12. Okay, this is the one that I wasn't paying attention. Ended up, it was pretty much the same on both forms. And so for the y-intercept, I'm going to set x equal to 0 and compute y. Y will equal 12 times 0 minus 9 over 12 times 0 plus 12. And that would be y equaling negative 9/12, which if you felt like you needed to simplify, that would be negative 3/4, but I'm kind of okay if you don't. Alright, on the back, we're going to consider the function given by f of x equals 3x minus 11 over x minus 4. And we're going to use polynomial long division to rewrite f of x. So, I'm going to say 3x minus 11 divided by x minus 4. Think about what do I take this first thing by and multiply it by to get the thing on the inside, and then what do I multiply x by to get 3x, and that would be a 3. Then I distribute the 3 over the x and the negative 4, and I get 3x minus 12. I subtract that. 3x minus 3x is 0. Negative 11 plus 12 is going to be positive 1. So I've got plus 1 over x minus 4. And so my rewriting of f of x will be f of x equals 3 plus 1 over x minus 4. Find the equations of the vertical and horizontal asymptotes to the graph of f. Well, luckily I've got it set up in a form that'll make it really easy for me to see. Okay, so for the vertical asymptote, that's going to be x equals 4. Because that's the x value that causes me to divide by 0, giving me bad behavior on the graph. Horizontal asymptote, that will be y equals 3, because the bigger x gets, the smaller the fraction part of that function gets, and the closer I'm getting to y equaling 3 plus 0. Okay, so sketch the graph of y equals f of x. Okay, I've got all the ingredients. I'm gonna just start by sketching in the the asymptotes. That was, what is that, x equals 4. Y equals 3 will be the horizontal asymptote. This is going to be a positive 1 over x graph because, because of that. And so I will sketch that here. No. Try that again. It's much better. And I can go in and say, all right, y-axis will be to the left of x equals 4. The x-axis will be below y equals 3. And yeah, feel good about that. That was a good sketch. I like that one. Alright, now the last problem here is let h of x equal 4 over x squared plus 3x minus 10. Find the equations of vertical and horizontal asymptotes of the graph of h. Alright, so the horizontal asymptote is going to be y equals 0. For a variety of reasons, all of which we have discussed many times. Okay, for the vertical asymptote, I need to find where the denominator equals 0. So x squared plus 3x minus 10 equals 0. So factors of 10 that add to 3 would be 5 and 2, so maybe x plus 5, x minus 2. And then that will be x equaling negative 5 and also x equaling positive 2. My vertical asymptotes. Right, yep, that's going to be all for this video. That's all for this quiz. Thanks for watching.